Hey everyone, and welcome back to HSC Maths Tutoring with Nathan, and today I'm going to be going over how to find the expected value of a probability distribution. So this is a brand new concept to the HSC syllabus for advanced maths. So people doing advanced extension, this is in the new 2-unit course. And I just want to go over quickly how to do it, and it is, I reckon, one of the easiest things in the world. I just want to show you what expected value means and how to calculate it from the table. So this is the full formula you'll see in the textbook. Expected value of x, where x is a random variable, and a random variable is just a variable that can take on random values, right? That's all probabilities. And then you'll have x sum, so sigma x p of x. So basically this big symbol means the sum of x times each probability. So what does this mean, x p of x? So if we look at this table, we have the score column. So these are all the values x can take, 0, 1, 2, 3, 4. And then we have a probability column. So probability of 0 occurring is 0.1, probability of 1, 0.2, and so on. And then we have this xp row. I think it's a column 4, but I meant row. So why xp of x? What does that mean? So expected value is that it's the value you expect to occur. So what we do is basically a weighted average, right? So basically that's why you'll see a lot of places saying expected value of x equals mu, which is the mean, because it's just a weighted average. That's what expected value is. It takes the score and multiplies it with its probability, which in this case is 0, to give it a weighting. So it gets its score and weights it with its probability. So all we do to complete this table is times down. Literally 0 times 0.1, 1 times 0.2, 2 times 0.3, 3 times 0.2. And we're missing a value here. So sometimes you'll see a value is missing in this probability row. And the one thing you gotta know is the probabilities always add up to 1. The sum of all probabilities always adds up to 1. That's the sample space. So if we add this is 0.3, 0.6, 0.8, then this is just 0.2. So then we can fill in this row. 4 times 0.2 is 8. So literally all we're doing is going down and timesing. That times that will give you this. It's x times p of x. And expected value is this number here. It's the sum, that's, as I said here, of all these numbers. So if we add all these numbers together, 0, 0.2, 0.8, 1.4, 2.2. So the expected value of this probability distribution is 2.2. And you can see it makes sense. It's fairly symmetrical. There's a lot of weighting on the 2. So the expected value would be close to 2, which it is. So what I want to show you is, so that's basically how to do expected value of probability distribution. It is very straightforward. What I want to do is extend it. And let's say I want to find the expected value of any random variable combination. So here we're just finding the expected value of the actual random variable. But what if I wanted to find the expected value of the random variable squared, so x squared? Well, the trick here is, in the formula, is replace x with whatever's in this bracket here. If it's x squared, I'm just going to put an x squared there. Let's say it was ax cubed plus bx. Then in brackets, I'm just going to put literally that, but with lowercase. So it'll be ax cubed plus bx and then p of x. That's literally how expected value works. It's just whatever's in the brackets next to p. But this last one here is not needed. This one's important. This one is to do with variant, which I'll cover in a different video. But let's put that at the end of here. Let's extend this table now. So if we want the expected value of x squared, we're going to need the x squared, sorry, it's a shocking too, p of x row. So what does that mean? How do we calculate this row now? Well, let's see what it says. It says x squared. So I get x, I square it, and then I times it by p. So this time I square this value here and times it with p. So 0 squared doesn't matter, it's 0. It's 1 squared times 0.2, or 1 squared is 1. 2 squared, 4 times 0.3, 1.2. 3 squared, 9 times 0.2, 1.8. 4 squared, 16 times 0.2 is 3.2, yep. That might be wrong, but that's just quick maths. So now we just, to get the expected value of x squared, this guy here, I just add all this together. So if I go backward, that's 5, 6.2, 6.4. And that is the expected value of x squared. So ideally for advanced maths, you don't need to really go past expected value of x squared. There is one other variation, which is x minus mu squared p of x, but I will cover that in a future video, that variation, because that's to do with standard deviation. So other than that, if you enjoyed today's quick video on how to find the expected value of a probability distribution, make sure to give us a like and subscribe for future videos, and comment below what you'd like to see in future videos for HSC Maths 2, 3 and 4 unit. Otherwise, I'll see you guys next time.